All right, guys, chapter 4, section 3 is hyperbolas. This is the last kind of conic that we're going to look at. So we've looked at parabolas, which are U-shaped, up, down, left, and right. We've talked about ellipses, which are our ovals, right? And now we're going to talk about hyperbolas, which is just an ellipse that's cut in half, and then the pieces of the ellipse go in the opposite direction. You'll see what I mean in a second. We will have a test on Monday, so we'll review in class on Thursday and Friday and just practice. You guys will be given the formulas on the test, right? There's going to be some multiple choice where you're just probably picking a few things here and there, and then there's going to be some where you have to graph the whole thing by hand, but a majority of it's going to be multiple choice. But you will have the formulas. So if you know what the different formulas look like, and you know what A equals, B equals, and C equals, your life will be not so bad, I promise. All right, first few slides are just talking about what a hyperbola looks like, that sort of a thing. There is a picture of a hyperbola. It's a set of all points, x and y in a plane, the difference of whose distance from two distinct points the foci is a positive constant. All right, I know that you guys are like, what? All right, do you see the picture of this hyperbola? Do you see what I meant when we had an ellipse, right? Your ellipse looks something like that. So if I cut it in half, hold on, my thing says optimizing. If I cut it like this, do you see how like if you flipped it, it would go the opposite direction? Like it would kind of open up if I cut it there. That's kind of the thought process that I have with hyperbolas and ellipses. They are, like if you were to flip this one this way, it would come like this. And flip this one this way, come like this, making it, you see what I'm talking about? You guys understand what I mean by that? Or you're just like, whatever, I don't know what you're talking about. That's just kind of how I look at it. Not that you have to look at it that way, I'm just saying that's how I kind of look at it. Your hyperbola can look like this, or it can, what do you think it can look like? Whoops, left and right, right? It can open up and down, left to right. Where is this hyperbola opening towards? The focus. Do you guys see that? Everything that we've done so far, everything opened, or the focus was inside, opens towards the focus. Everybody remember that? There's a constant theme with our conics. That's good to know. Let's look at the next little piece here. Vocabulary is important so you guys know if I say something, you know what I'm talking about. These little, we call them, some of you guys are like wings, half parabola things. What they're called in a hyperbola is a branch. So you have two branches in a hyperbola. You either have one going up, one going down. You have one going left, one going right. But what is important to notice is a lot of the things in our other conics are still existing. What do we have right here? The center, okay. What do we have right here? The vertex, good. And then what are these? The foci. Same exact stuff. What do you notice about all of those pretty colors? My blue, my green, and their red. Are they all on the same axis? That's the transverse axis. The same as with our ellipse. Remember all the important stuff was on the major axis? So all of the important information, guys, is on the transverse axis. Do you think this is a vertical or is this a horizontal? Is this a vertical parabola or a horizontal parabola? Not parabola, hyperbola. Horizontal. It's a vertical. Which way is it opening? Up and down. Which way do you think the horizontal's open? Left and right. Okay, so very, very, very similar are all of our conics. There's minute differences in each, which makes it the hard part. The center is at the midpoint of the transverse axis. That should make sense to us. Guys, if the center's at 0, 0, it makes life real easy. One thing that I do want you to write down, this is very important. This is a little different from our ellipse. Now, what does this say? It says the first variable you see will be the axis that your graph is transversing. What does that mean? In the equation, when your equation is written in standard form, the first variable you see will tell you if it's a vertical hyperbola or a horizontal one. A vertical meaning it opens up and down, your branches, or horizontal, meaning it opens which way? Left and right. Your center, you need to remind yourself, your center is the midpoint between the vertices. If I could spell, it'd be great. Look at this little picture. What is your A value? What's the distance from where to where? Center to vertices. Is that constant with everything else we've been doing? Yes. What is your C value? Center to foci, which is what we've been talking about. So nothing changes. Your A, B, and C, you still focus that A is from center to vertices. C is center to foci. If we have a vertex in whichever shape that applies to, you guys should know that when I say that, that's your B value. But everybody with me so far? All right, nothing really crazy. All right, here is the equation. This is what I told you. This is what trip us up a little bit. But again, you're going to be given the formulas. How is this, the two standard equations in yellow, how is it different from an ellipse? The only difference you see is what? A subtraction. All right, so in a standard form of an equation of an ellipse versus the standard form of the equation of a hyperbola, the only thing that's different, guys, is that sign in the middle. What do you notice about the C squared formula? You're adding instead of subtracting. So they're opposites of each other. That's something you guys have to remember. If I were you, I'd make yourself a little cheat sheet that has the standard form and the C squared formula for both the hyperbola and an ellipse, and I would put it next to every single problem you do, because you're going to be given the formulas, so easily you guys can look at it and say, okay, this goes for this one, this goes for that one. That makes sense? A little bit? All right, so what I want you guys to remember, what did I say? The first variable is going to tell you what kind of a hyperbola you have. Because remember, guys, we're dealing with subtraction. So does order matter? Yes. In the addition one, in our ellipse, remember your whichever A squared was under, that's what determined which way your ellipse went, correct? In this case, A squared is always the first value. So write that down. A squared, not A to the S power. A squared is always first. Always. Always, always, always. So when you have x squared over a squared, it's a what? Horizontal. When you have y squared over a squared, it's a vertical. Good. All right, does that make sense? Do you see how in this first one it's a horizontal because x squared is first? Second one, y squared is first, that's why it's vertical. Everybody with me? All right, now, what do you guys see that we have not talked about with any other of these wonderful conic sections? Okay, transverse axis, that's where all the major stuff is. That's good, that's good. What else? Asymptote. Remind me what an asymptote is. Okay, it's a boundary line. Hi. All right, the asymptotes. Remind yourselves again, guys, asymptotes are boundary lines. Are they solid lines that you draw? No, they're just like dotted boundary lines that your graph gets really close to but does not what? Touch. All right, we're going to talk about the equation of your asymptote. It's going to be y equals mx plus b in that form. But there's a specific thing you have to do is put a over b, b over a, that sort of a thing. All right? You'll see it in a second. Everybody okay? All right. First few slides are just lots of notes. Okay, here's our asymptotes. When your center is at 0, 0, this is how you find the asymptote. If it's a horizontal, it's plus minus b value over a value. Think about why there's no plus a number here. Why is there no plus a number there? Where's your center? At 0, 0. You're going to go right through the center, and you're going to take whatever your B value is and put it over your A value. We're going to do some examples here in a second, and you're going to be fine. And then conversely, I should say, if it's a vertical hyperbola, then your asymptote is going to be at plus or minus a over b. And again, once we do this in a second, it'll make life a little easier, I promise. All right, we okay? All right, let's put some numbers to this. That's usually when things get a little easier. All right, find the center, vertices, foci, asymptotes, and graph. Let's talk about graphing because you're going to have to graph these. So let's give ourselves some steps. First thing I would do when you're graphing, let me try and write this nice and neat. That's not very neat. I would graph the center. It's always good, guys, to give yourself a picture. Graph your center. The second thing I would do is graph the asymptotes, so you know where exactly, whoops, asymptotes. Then I would graph the vertices. And then I would draw. You'll see what I mean by that in a second. But that's the order I would go. I would focus on where is my center. Then from there, if you're at the center, you're at the origin, you start your asymptote there and you just follow the slope. We'll talk about that in a minute. And then put your vertices, and then you'll see how to draw your branches. Well, I would do that last. We'll put it here. Because remember, your branches are going to open up towards it. So that'll be, like, I mean, you could put it in whenever you wanted to, but it's really important to get the center and the asymptotes in there. All right, so let's think about this for a second. Is there anything being added or subtracted to my x squared and y squared? Now, do I have a parenthesis that says like x minus 4 quantity squared plus? No. So where is my center? My center's at 0, 0. Do they have to implicitly tell you center is 0, 0? No. You guys should now be able to recognize if it's going to move somewhere, it's going to be in that kind of a form. All of them are going to be in that kind of a form if it moves somewhere. If your x squared and y squared are not, nothing's being added or subtracted to, it's just hanging out at 0, 0. So there's no h or k, there's no shift, we're just at 0, 0. The equation of your hyperbolas is either x squared over a squared minus y squared over b squared equals 1, right? Or y squared over a squared minus x squared over b squared equals 1. What's the first thing I need to do to example number 1? Divide everything by 16. We need this to equal what number? There you go. So what does my first term become? X squared over 4, perfect, minus y squared over 16 equals 1, all right? Now, I know a lot of stuff just by looking at this. First of all, is this a hyperbola or an ellipse? Why is this a hyperbola? Because there's a minus sign that you just put on my desk, thank you. No, that one, thank you very much. All right, so I know in a hyperbola that a squared is always which denominator? The first one, I know that this is my a squared and this is my b squared. So I'm going to say a squared equals 4. So what does a equal? What kind of 2? Plus minus 2, okay. So b squared equals, not 16. So b equals plus minus what? 4. All right, great. If you need to remind yourself, guys, what is the a value? Distance from where? Center to vertices, okay? I shouldn't write, hold on, let me write the word center. So it doesn't look like C. We say, oh, okay, so think about this. What kind of a hyperbola do I have if it's an x squared? Horizontal. So that means get a mental picture, guys. Where are your branches opening towards? Left to right. Okay, so let's go ahead and let's talk about what this looks like. Here's your x and y. Where is your center? It's at 0, 0. Does everybody agree with me? Okay, good. Excuse me. Do we have enough information, excuse me, to figure out my asymptotes? Look back at the asymptote slide. What are the two values you need to find your asymptotes? The A and the B. Do we have that? Yes. Okay. So think about if I'm going to find my asymptote, what kind of an asymptote am I going to have? Is it a vertical one or a horizontal one? All right. So your horizontal asymptote. What's the formula on that sheet, on your little cheat sheet? Y equals what? Plus or minus B over A times X. So let's write our equation of our asymptote. Let's write our equation of our asymptote. Plus minus 4 over 2x. What's my y-intercept? Where does this asymptote cross the y? Where is the center, guys? 0. It's going right through the center. If you're centered at 0, 0, you're not moving up or down the y-axis. So if I was going to simplify this, what's 4 divided by 2? So this is plus minus 2x. So I have two asymptotes. One is at y equals 2x, and one is at y equals what? Negative 2x. Does everybody in here know how to graph that line? Absolutely. We're starting at 0. What is your slope? Okay, 2 and negative 2. So I'm going to do the positive line first. I'm going to start at 0. I'm going to go up 2 and over 1. Then I'm going to go up 2 and over 1 again. Then I'm going to go down 2, over 1, down 2, over 1, and something like this. Is it going to be perfect on yours? No. It's going to be perfect on mine? No. All right, now same thing. We're going to do the other asymptote. From here, we're going to go down 2, over 1 this way, down 2, over 1, up 2, over 1, up 2, over 1. It goes like this. Now, why are the asymptotes important? You can already, with not even putting your vertices or your foci on here, you know what your graph should look like. When you draw your branches, they get really close to the asymptotes but don't touch, correct? Are they on the top and the bottom of the asymptotes, or are they on the left and the right? Why do you know they're on the left and the right? You're correct. Because they're what? Because it's a horizontal. Good. So the more you guys can give yourself some notes of, okay, this is the way it's going, this is what, the more you write down, the more you label, the easier things can get. So let's talk about where our vertices are. How would I figure out my vertices? And I'm going to pick on you, Isabel, in a good way. Isabel did something I think is really good yesterday when she came up to ask me a question. In order to find her vertices and stuff like that, she wrote her center and then wrote what she was adding and subtracting underneath either the corresponding X or Y. It really makes you be able to see it. Meaning, her center here was at 0, 0. If I am going to find my vertices, think about where my vertices are. Are they on the X-axis or the Y-axis? The X. The X. Because this is a horizontal. So I'm going to add and subtract what number? 2 to what letter? So she does this, plus minus 2. That's so smart because you actually are seeing. It's so easy to make a silly mistake here. So your vertices end up being at 2, 0 and what? Negative 2, 0. Perfect. So go ahead and put those on there. So I'm going to go to 2, 0 and negative 2, 0. There's my vertices. Your A value. Now I need to put my foci on there. What is my F value, my foci? How do I find the foci? Your C. Okay, so I have A and B. Oh, wait a second, I don't have C. How do I find C? C squared equals A squared plus B squared. What theorem is that? It's also the Pythagorean theorem. Okay, so my A squared is 4 plus B squared is 16. So C squared equals the square root of 20. So C equals plus minus 2 root 5. So again, if we're going to find the foci, I'm taking my center of 0, 0, and I'm adding what to what's up? Yeah. So c squared is 20, then I took the square root. Like I took the square root of both sides.
All right.
So now I'm going to add and subtract 2 root 5 to the x value, correct? You guys with me?
Yeah.
Okay. So my foci is at 2 root 5, comma 0, and where? Negative 2 root 5, comma 0. Do you guys know exactly where 2 root 5? No, not exactly. But let's think about it. So the square root of 5 is close to the square root of 4, right? What's the square root of 4? So 2 times 2, so I don't know, like 4 and a bit-ish. Don't get hung up on exactly where that is. So we'll say 4 and a bit. So 1, 2, 3, 4, 1, 2, 3-ish. All right, there's my foci. And then I have negative 2 times 4 and a bit-ish. It's going to give me over here-ish. You guys kind of see what I'm talking about? So when I draw, my branches are going to get really close to what? The asymptotes. It's going to go through what? The vertices and open towards the foci. Look at you guys. Are these problems incredibly difficult? No. Is it a lot of little things to pay attention to? Yes. Is it kind of a pain in the butt? Yes, I agree with you. I can't wait to grade all of your graphs. All right, let's go through this one kind of quickly. Kind of quickly. It's the exact same thing that we just did. All right, we'll be able to look at everything, find everything. How is this one similar? Are we moving from the origin? No. Where's your center? At 0, 0. Some of you are sitting there looking around going, how does she know it's at 0, 0? Explain to me how we know it's at 0, 0. Nothing is being added or subtracted. I should write the word center. Nothing is being added or subtracted to y squared and x squared. All right, what's my next issue I have to deal with? Divide everything by 100 because we want our equation to be set equal to what number? To 1. So this is going to give me y squared over what? Perfect. Minus x squared over 25 equals 1. All right, we know a ton of information now. What do we know? This is a vertical. Why is it vertical? Because y squared is first. That means my branches are moving or opening in which direction? Up and down. Perfect. Perfect. So what is my a squared value? 4. So a equals plus minus 2. What is my b squared value? 25. So b equals plus minus 5. Do you guys want to go ahead and find c squared? Find your foci value? Sure. So c squared equals a squared plus b squared. So 4 plus 25, c squared equals 29. So your c value is the square root of 29. How much is square root of 29? It's a little bigger than what? 5, okay. If it's helpful to you guys, do this. Come over here to the side and say a equals plus minus 2. B equals plus minus 5. C equals plus minus root 29. Give yourself that little cheat sheet. Tell yourself this is from center to vertex. This is from center to foci, right? Whatever you need to do to say, okay, I've got to count. This is where I look to count. But let's go ahead and draw a quick little picture. Where is my center? 0, 0. Perfect. How do I figure out my asymptotes? Y equals plus minus a over bx, right? Why is this one a over b? Because it's vertical. So I have y equals plus minus, what is my a value? 2 over what is my b value? 5. Do I know how to plot that line? Or those lines, I should say. All right, so let's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All All right, so from the origin, I know it's from the origin because that's our center. I'm going to go up 2 and to the right 5. 1, 2, 1, 2, 3, 4, 5. And then I'm going to go down 2 and left 5. 1, 2, 3, 4, 5. So something like this. And I'm going to do the exact same thing, but in the other direction for my negative. So left 2, up 5. 1, 2, 3, 4. Left 2. 1, 2, 3, 4. Left 2, down 5. Did I go over too far? No, it's just my lines are not spaced very well. It should look something like this. It's just because my tick marks aren't great. But we got our slope, right? Up 2 over 5? Okay. So think about this. I have my asymptotes. What kind of a hyperbola do I have? It's a vertical one. So where are my branches going to be? Above and below or left and right? Above and below. Good. Very good, guys. So let's talk about where stuff is. Let's talk about where my vertices are. Think about where our center is at 0, 0. So I'm going to add and subtract what number to what letter? Plus minus 2 to what? To your y. Very good. So we're at 0, 2 and at 0, negative 2, correct? Okay, so up 2, down 2. Everything's so much easier when we're at the origin, isn't it? That's the hardest part. Once you move... How to get the vertices? Okay, well, I know it's a vertical, so I know I'm going to be adding and subtracting to the y value. And your a value tells you how far the center is to your vertex. You see how a is plus or minus 2? Yeah. So you add and subtract 2 to y from the center. Yeah, 0, 2, and 0, negative 2. Oh, yeah, that's what I put.
That looks like a 4, sorry. This is a silly question, but
all right, let's talk about where our foci is. What are we adding and subtracting to the y value to find our foci? Square root 29. To what? Tell me.
do the lines of arrows or no? The hyperbola?
You can put, yeah, that's fine. So we're going to be at 0, comma, root 29 and 0, comma, negative root 29, right? And where do we say root 29 is? About 5. So we're going to go 0 up 5-ish. 1, 2, 3, 4, 5-ish. And then down 5. 1, 2, 3, 4, 5-ish. And then we're going to draw. Close to our asymptotes, don't touch. Go through your vertex. The hardest part, I believe, if you didn't have the formulas, this is really hard. But if the hardest part of all of these is going to be our next example, and the only thing that makes it difficult is you're going to have to like add and subtract like 2 root 29 to the x or y value. That's the part that you guys get confused with, and I'm not exactly sure why, but that's okay. You'll be all right. Let's look at the last one. I'll do 3 with you guys, and then 4 I'll probably do on the video. How is this one a tad bit different? Well, the only thing that changes is where are we not anymore? We're not at the center. We're moving from the center. So what you have to think about, guys, is you're going to have to say, okay, when I move from the center, I have to really pay attention to if it's vertical or horizontal. So when you're finding out where your foci is or where your vertices are, you're adding the correct number to the correct letter. It's not just going to be to 0. So you got to pay attention. Another thing that changes a tiny bit is your asymptotes. You're still going to have an equation. Notice what the only thing that's different in your when you're not at the center. What's the only thing different in these two equations? Whether it's b over a or a over b. If you had a horizontal, the first example we had a horizontal. Our asymptote was at y equaled b over a times x, correct? If you had a vertical, it was a over b. Nothing changed about that. The only thing now is we have to account for our center. But again, you're going to be given these, so you just need to understand that your horizontal asymptote is b over a, the vertical one is a over b. we're still going to find all the stuff the same. All right? Let's go to one example, and then I'll do the last one on the video. All right, so let's talk about what we can identify just by looking. First of all, if you had to name this conic, is this a parabola, an ellipse, or a hyperbola? How can you tell, other than we've been working on hyperbolas? The minus sign in the middle, okay? Where is my center? All right, let's make sure that we said that right, because remember, our center is your H and your K, your X value, and then your Y. Don't get confused. Don't just say, okay, the first one is 2, so it's negative 2. It's not. Your H value is what? Negative 3. And what is your K value? Negative 2. Whatever is with the X is your H. Whatever is with the Y is your K. Does everybody see that? All right, we're set equal to 1, so that makes life a little easier. Let's go ahead and say what kind of a hyperbola we have. Where are our branches opening towards? Up and down or left and right? Up and down. This is a vertical. Why do I know this is a vertical? Because y squared is first. Okay, great. We already have a picture. We already have a mental picture that I'm moving left 3 and down 2, and that my branches are going up and down. You should be able to visualize that as you guys are going through. So let's go ahead and talk about our a and b values. What is your a squared? 9. So your a value is plus minus what? 3. All right. B squared is 4, so B is plus minus 2. Want to go ahead and find C? Okay, C squared equals A squared plus B squared. So 9 plus 4. You guys with me? C squared equals root 13. I'm sorry, C equals root 13 plus minus. So let's just say A equals plus minus 3. B equals plus minus 2. C equals plus minus the square root of 13. It's actually quite nice when the root doesn't break down, because then you can sometimes easier visualize where it is. Like if you have 2 root 5, you have to think, okay, what's the square root of 5? And multiply it by 2. If I just say what's the square root of 13, it's in between the square root of 9 and the square root of 16. So it's in between where? 3 and 4, right? So think, you have all the stuff now that you need to figure out everything. Your A value is the distance from where to where? Center to the vertex. Your C value is the center to the foci. Okay, good. So we can already mathematically figure out where that is. You're going to add and subtract 3 to which value of your center? The X or the Y? But yeah, you're going to add and subtract. To find your vertices and your foci, you're going to add and subtract 3 and root 13 to the Y value, because you already know it's a vertical. So all of those things you guys should be able to talk through. So let's go ahead and find our asymptote. Y equals, which equation we're using for our asymptote? Go back to the last slide. It's a vertical. What's the equation? K plus minus A over B times X minus H. Okay. Do we have all the stuff we need to throw in here? Yes. Okay. So let's just go ahead and do that. What is our K value? -2 plus minus, what's A? 3 over B is 2 times X minus, what's our H value? -3. You guys with me? All right, there's some algebra here we got to do. It's okay, we're in Algebra 2 Honors, we can do it. Y equals -2 plus minus 3 over 2 times X plus 3. You guys agree? Okay. What should I do now? Where should I go from here? Told you this is the hardest part. It has nothing to do with the Algebra 2 conics concept. This goes back to Algebra 1. What should I do here? Well, I don't want to distribute yet. How do you distribute plus minus, guys? How many equations do we have here? We have 2. Let's write them into 2 different equations. I have y equals -2 plus 3 root 2, not 3 over 2 plus times, sorry, x plus 3. And then I have y equals negative 2 minus 3 over 2 times x plus 3. Agreed? All right, now what do we need to do? Now what can we do? We could distribute. So go ahead, let's do that. So I have negative 2 plus 3 over 2x plus what? 9 over 2, okay. Now what? Okay, what's my common denominator? 2. So if I change this to a 2, do you guys agree this becomes a 4? So this becomes y equals 3 over 2x, what? Plus 5 over 2. Perfect. So same thing over here. Boop, boop. So I have negative 2 minus 3 over 2x minus 9 over 2. Agree? Okay, so let's change this to 2 is 4. So y equals negative 3 over 2x 13 over 2. Good. Now, are these beautiful lines to graph on a coordinate plane that we make ourselves? No. Where is my intercept? 5 over 2. Where is 5 over 2? 2.5, right? So from 2.5, I have to go up 3 over 2, up 3 over 2. Then I have to find negative 13 over 2. Okay, this is the hardest part, is graphing this kind of nonsense. And I understand that. Mathematically, I want to go through and finish everything, and then I'll do number 4. But I have no idea what the graph is going to look like on your test. So yeah, you might have fractions. I don't know. Yeah, I'm not sure. But just understand that the hardest part, I think, is the Algebra 1 stuff. Where you guys are like, oh, I have a fraction, I have to graph it. But it's really not that bad. Let's find our vertices. Let's go back and find our vertices. Again, how do we find vertices? What value is that? It's our A. We're going to take our center, negative 3, negative 2, and I'm going to take my A value, and where am I adding the A value? To the Y. So I'm going to plus and minus what? 2, right? So I have a vertex at negative 3, comma what? You're right, it is. Thank you. Negative 3, negative 5, and negative 3, 1. How do I find my foci? I'm going to take my center, which is negative 3, comma negative, why am I writing in black? Negative 3, negative 2. And what am I adding to where? Plus minus the square root of 13 to the negative 2. So my foci is going to be at negative 3, comma, negative 2 plus the square root of 13. And at negative 3, comma, negative 2 minus the square root of 13. Everybody agree? All right, quick pick. Negative 3, negative 2 is my center, so there-ish. My negative 3, negative 5. 2, 3. 1, 2, 3, 4, 5. Negative 3, 1. So there, my vertices, right? My foci is going to be a little bit outside of that. And then when my intercepts, I'm going to start at negative 3. Or if I'm going to graph the line, I'm going to say, okay, 5.5. Or sorry, 2.5. I'm trying to go fast. I'm saying silly stuff. And I'm going to go from this point here-ish is my intercept. I'm going to go up 3 over 2, up 3 over 2. So it's something like here-ish. And then when I do the other one, it's going to be here-ish. And then when I graph my branches, it gets close to, but doesn't touch. Now again, I assure you, on your quiz or test, whichever this appears on, could be both, see it on the midterm at some point, whatever, you will have a graph that you don't have to do by hand. You have to do all your tick marks and stuff because that's too hard. I understand it's very hard. When we have whole numbers, it's a little easier. But when you're trying to plot intercepts that are fractions and then, or radicals, it does make it difficult.
Could you say that again?
No, Siri, I'm not saying that again. Just understand how to find everything. I'll do the next example on the video before I upload it. I'll do it at lunch. And then you guys will finish. We're going to do the reverse tomorrow. We're going to be given the foci and that sort of thing. We're going to go backwards, write the equation, which isn't bad because I think graphing is the hardest part. And then Thursday and Friday, we'll just practice. I'll give you guys a bunch of stuff to practice to getting ready for our test on Monday. Sound good? Okay. Okay, guys, so when we're looking at this next example for number 4, we can see clearly that our center is going to be, center is going to be at our H, comma, K. So the H value would be positive 3. Your K is going to be positive 2. This is going to be a horizontal hyperbola because our x is first. Our a value, or our a squared, is 1, so our a value is going to be plus minus 1. B squared is 9, so our b value is plus minus 3. And we can go ahead and find our c value, so c squared equals a squared plus b squared. So I have 1 plus 9, c squared is going to give me 10. So take the square root, and c is going to be square root plus minus 10. So let's think about this for a second. From our center, you're going to add and subtract 1 to what value? It's going to be our x value because we're going to be moving left and right. You're going to add and subtract radical 10 to your x value to find your foci. This is to find our vertices. So you can kind of already envision where your center is, which direction your hyperbola is going to open, where your vertices are, and where your foci are. So let's go ahead and figure out where those values are. So I'm going to say my center here is at 3, 2. So I'm going to add and subtract 1 to my x value. So my vertices are going to be at 3 plus 1 is 4, 2, and 3 minus 1 is 2, 2. Those are going to be my vertices. I'm going to find my foci. Right? My foci, we're going to take our center, which is 3, 2, and we're going to add and subtract the square root of 10. So the square root of 10, guys, remember, is a little bigger than the square root of 9, which is 3. So I'm going to say 3 plus the square root of 10, 2, and 3 minus the square root of 10, 2. Now, for graphing purposes, remember, this is about 3. So this is about 6, 2, and this is about 3, so it's about 0, 2. So if we want to go ahead and give ourselves a quick little picture, if you wanted to, you can wait until you get your asymptotes, however you'd like to do it, but our center's at 3, 2, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. So my center's at 3, 2. 1, 2, 3, up 2. Where is my center? I have my vertices at 4, 2. So 1, 2, 3, 4, 2. And at 2, 2. So 1, 2, up 2. I have my foci at about 6, 2. So 1, 2, 3, 4, 5, 6, 2. And about 0, 2. So... And I know I'm going to open left to right. So now let's figure out where. So now I'm going to figure out where my asymptotes are so I know the boundary lines to draw and get really, really close to but not touch. So since this is a horizontal, my asymptotes is going to be at y equals k plus or minus b over a times x minus h. So I have y equals, my k value, again, is 2, plus or minus b over a. So that's going to be 3 over 1, times x minus my h value, which is 3. So I have my asymptotes at y equals 2 plus or minus 3 times x minus 3. Now remember, guys, we have two equations here. I have y equals 2 plus 3 times x minus 3. And I have y equals 2 minus 3 times x minus 3. So let's go ahead and algebraically work this out. We'll distribute our 3. So we have 2 plus 3x minus 9. Combine like terms. So you have an asymptote at y equals 3x minus 7. And then here we'll distribute here. So we have 2 minus 3x plus 9. Combine like terms. So an asymptote at y equals negative 3x plus 11. Now, a little shortcut, guys, that I'll talk to you a little bit more about tomorrow. But once you determine your asymptotes, your equation, your asymptotes, right? You have to have them. But the way that you can go ahead and find out exactly where your asymptotes are without actually having to graph those lines both together, you can go from your center and use the slopes from your asymptotes, meaning we've already moved our center to over 3 up 2, so you can go from just your slope here to draw your asymptotes, meaning from my center, I'm going to go up 3, 1, 2, 3, over 1, down 3, 1, 2, 3, over 1. Here's one of my asymptotes. Then I'm going to do the same thing. I'm going to do the negative. So I'm going to go up 3 and over 1, down 3 and over 1. So that's the shortcut for graphing. You're going to need to write the actual equation of the asymptote, which is here. But for graphing purposes, if you don't want to find the actual y-intercepts and that sort of thing, you can just go from the center, wherever you've moved the center to, and use just the slope. So when we draw, we're going to go through the vertices towards the focus, and you want to get really close to your asymptotes but not touch. And your graph looks something like that.